Okay, I'm now going to move in to what I call analytical trig. The questions they ask is just based off your basic trig knowledge. Now this one, it shows up as a circle. If it's a circle, I want you to know you can always do circles as polar. And how do we do polar? We already made video on this, Desmos. You can always use Desmos. But I'm going to do this as the oh shoot. Oh shoot, I forgot. Because the oh shoot, I forgot page is actually how to do analytical trig. Basically, you summarize what we've done the second semester. It's a trig. So here's how I would do it if it's like, oh, I forgot what I'm doing. I don't remember Desmos. Here's how I would do it if I were you. Let me clear my ink. I want you to think of that sine is what? What is sine? Y over h. Sine is y. What is cos? X. X over h. Tangent is. And then finally, you need to remember the Pythagorean theorem that connects the x and the y and the h. X squared plus y squared equals. Okay. If you remember that and you remember the basics that H stands for what actual word? Starts with the H. Hypotenuse is the same thing as R, and R stands for radius, which is the same thing as magnitude. All three of those are equal to one another. So that helps you in the oh shoot stage, knowing them all together. What did they give us in this problem? That's 16. What is the 16? It's half of a circle. What would that make it? A radius, which means for my formulas, I could plug it in as an h. I could say this is 16, this is 16, that's 16.
So with the h, is it 16 squared or just 16?
On the sine, it's just 16. On the cosine, it's just 16. Over on the Pythagorean theorem, you would put 16 squared. Okay? Now, they gave me something right here. What is that? Theta. Now, you can know that because it says radians, or you can know that because they always come in pairs. X and Y is a pair. H and theta is a pair. Or R and theta in this case. So, let's go to our problem. That means this is 35 pi over 6. This is 35 pi over 6. This is 35 pi over 6. So how do you solve? You choose the equations that only have one variable left over. So there's 4 equations up there. Okay, Brian, you think you know the answer. I'm going to have Brian answer this one. Out of those 4 equations, only 2 of them have only one variable left over. Which ones are they? These 2. This is what would solve this problem. And that's how I would do, this is going to be the oh shoot page, if you will. I would solve it like this. So I'm just going to use insolve. So go to your calculator. And how do we do an insolve? Menu 3, 1. The only thing that'll be a little bit different is when I press this sine button, it's going to add a parenthesis. So 35 pi over 6 is the angle. Let's type that in. So fraction 35 pi over 6. Now, they put a parenthesis right here. Let me add it on the packet. So I'm going to put a parenthesis right there. So you're going to have to close the parentheses after the 35 pi over 6. The same will happen on cosine. Okay, so back over. So go outside that first, the sine parentheses, put the equal sign, and now do y over 16. And do comma y, because that's what we're solving for. Let me give you a second. Did you all type it in? What'd you get?
-8.
Perfect. So the answer has to have -8 as a y, because sine is y. At this stage, do we know the answer? Yeah, which one's it? Well, let's just prove it. You said we could also use cosine. I'm just going to copy and paste, press the up arrow twice, press enter. For cosine, COS. And that changes the y to become now a x. Okay, and I want to see if that's 8 squared to 3. 8 square root of 3. Is it?
Yes.
If it is. All right, moving to the next analytical trig problem. So which two angles are coterminal? So this one is vocabulary. Coterminal. What does the word terminal mean? End, the ending. Co means together. So they end together. They end together. So it was basically saying, if you looked on the graph, we could go to Desmos if we wanted to. I'm going to go to Desmos here. Where does pi over 3 end? First quadrant, good. Up here somewhere. So I'm going to say that right there is pi over 3. Pi over 3. What we're looking for are answers that end together. So here's how you can remember that. On the graph, the things you need to have memorized as well for analytical trig. It's not just those 4 formulas. You need to remember 0 goes on the right. In terms of pi, what would you put on the left axis over here? That's a pi. Again, you can get that off the right there on Desmos. And then if you go all the way around, how much is it? 2 pi. That's 2 pi. Okay, so an example of coterminal are these two. These two are coterminal. They end together. 0 and 2 pi end together. They're different math numbers, but they end together. And that also is the formula for how to find coterminals. You either add or subtract a full circle, which in this case is 2 pi. Now you could type it in the calculator without pi's, but I just think the easiest way is if you think about the denominator, what we're really saying is it's 1 pi over 3 plus or minus 2 pi's, which in terms of a 3 is just 2 times 3. So if I add it in, make it a common denominator, what is 2 times 3? 6. I would either add 6 or subtract 6 to the numerator. That's all you do. With fractions, the denominator does not change. So what is, if it was the plus, what's 1 plus 6? So 7 pi over 3 is an answer. And this, by the way, is an example of an enhanced problem. There's more than one answer. You'll have 2 of these on the test. And now, what is 1 minus the 6? -5. That would be your other answer. So visually, 7 pi over 6 is this. It goes all the way around for 2 pi and then goes to the spot. So they end together, but the angle it made an extra circle. And then -5 pi over 6 would be as if you went around the circle this way. That would be the -5 pi over 6. But either way, they all end together. Okay. 18 is similar, but it doesn't use the word coterminal. It says reference angle. So you still need to know your axes. You could come over to this, Desmos, switch degrees to see them, but hopefully you just have them down. 0 always starts in the top right here. That's 0. What do I put on the left in degrees? 180. So 180 is the same thing as pi. And then what is 2 pi then? 360. Okay, and then the problem, -1615. What's the problem with it? Too small. It's good. Changing it to small from big. It's too small because it's negative. So what do we do? Add 360. Yeah, it smells like burnt popcorn, doesn't it? I don't know what that is. So I'm gonna go to my calculator here. -1615. Whoops. There we go. Let me take away the answer. Plus 360. What is that? Is that a good number? Still too small. So I add another 360. So this is the second 360. What about that one? Too small. I'm gonna add 360 again. That's the third time. Still too small. Fourth time. Too small. Fifth time. It's negative. It's not between 0 and 360. It's just easier. I added it 5 times. 1, 2, 3, 4, 5. So just for the sake of the video, I did this 5 times. We added 360 5 times. 5 times 360 there. And we got as our answer 185. So what is a reference angle? The only thing different with the reference angle. So all those, by the way, in the calculator, all these over here would be called coterminals. They all would end together. But what is reference angle? Well, if this is 185 degrees somewhere over here, a reference angle is the angle that connects it to the closest x-axis, that angle right there. Now, how many degrees is it from 180 to 185? 5. The answer here would be 5. So that's the difference between reference angle is coterminal, is the final answer is actually gonna be the closest x-axis. Coterminal just means they end together. So this, we found 5 different coterminals. Every one of these on the calculator, negative 1255 was coterminal, negative 895 was coterminal, negative 535, negative 175, positive 185. Those are all coterminal with negative 615. But the answer to reference angle is that's 5 degrees away from 180, nearest x-axis.
So if the number was higher, let's say 200 and something, so it was on the other side, it will minus 360.
Yeah, let's just say the number was 290. If that was our number, then 290 would be somewhere over here, because this is 270. That's 290. The closest x-axis is now this x-axis. How far away is it now? From 360? 70. So this would be the reference angle. Yep. Oh, my goodness, my spelling, I forgot. Well, let's just erase that. Reference angle. How about RA? You can't spell, use initials. Reference angle would be 70. And you can do it with pi's as well.
Oh.
So just to make it easier on, I'm gonna go to Desmos. If the angle was 11 pi over 6, that's 11 pi over 6. You'd say, what is 11 pi over 6 closest to? It's closest to 2 pi. I know Desmos doesn't show 2 pi.
So minus.
Yeah, which 2 pi would be like 12 pi over 6. So there's only 1 pi over 6 apart. So if the angle was 11 pi over 6, the answer would be 1 pi over 6, because that's how far away it is from 2 pi.
Okay.
Okay?
What if it was like 5 degrees? 70 0 is
Yeah, so let's say the angle was pi over 3. The answer would be pi over 3 because you're comparing it to 0. Pi over 3 is pi over 3 more than 0. So the first one, or if it was pi over 6, the answer would be pi over 6. That's greater than 0. The ones that are harder, I think, so like 4 pi over 3. 4 pi over 3 is in the third quadrant. That's closest to pi. How much difference? Well, pi is like 3 pi over 3. This is 1 pi over 3 more. 4. So it'd be 1 pi over 3. Okay, and let's just finish off. We got a few in these sections. With pure analytical trig, you can use the calculator here. It says what has a positive cotangent and a negative sine. So how about this? Just so you can type these in real quick. A, B, C, D, A. Type in the cotangent of whatever angle I just gave you. So instead of, I'm using cotangent because that's what it says here. Put the answer choices. So I have an A, a B, a C, and a D. And then, yeah, just put your answer choice in and press enter.
This is the end of C lunch.
See lunch. Okay, so cotangent either pi over 5, 4 pi over 5, 6 pi over 5, and 9 pi over 5. We have one more thing here. Equals. Okay, let's answer choice A. Have we done A yet? What'd you get for cotangent of 5 pi over 3? 1.36. Okay. So would this be a possible answer?
Yes.
Possible answer. And so you would try sine. Okay, let's move on to the next one. What if you tried, if you did not use pi over 5? What if you tried 4 pi over 3? Who typed that one in? Negative 1.376. Good answer, bad answer? Bad answer. So this one is eliminated. Okay, what if we tried C, 6 pi over 5, 6 pi over 5, what'd you get? Good or bad? Good, so C still in the running, possible, these two are possibles. And then D, negative 1.376, so is D any good? No, and so now you can just go and try sine. I can help you out. This is first quadrant here. Will sine be positive or negative in the first quadrant? Sine, think of the y's. Sine is y. Will you get a positive y or a negative y there? positive, and you need a negative, that won't be it, the answer would be C. If you tried that with sine, you get a negative number. So you can do those that way. That's why on the cheat sheet it just says plug in. 2. It might not be asked like that. They could ask it. I guess I don't have one exactly like it. They could ask it something like 21. I'll get to 21 in a second. But let's do 20. It says here in triangle ABC, AC is 89. So AC is 89. What would you call that? XY or H? H. And it says BC is 80. What would you call that? So we're missing the Y. You could do Pythagorean theorem, but I'm looking at the answer choices. What's the only new number on there? 39. That's got to be the Y. And so here, this comes back to what I was saying for analytical trig. You need to have memorized. This is oh shoot page. That sine is what? Y over H. Cosine is tangent. And we could do the Pythagorean theorem. You won't need that on this one. Like process answer choices tell you there's only one possible x value, which we got is, or a y value, I'm sorry, 39. Okay, on this one, let's check them out. CSC. Okay, how about this? If you don't know those, because I didn't tell you to memorize them. Good. If you use the calculator, I'll just use this one because it's smaller. If you press the trig button, they go in order with each other. So sine, cosine, tangent. Sine's reciprocal. Cosine's reciprocal. Tangent's reciprocal. They just flip. They go in order. So CSC, secant, cotangent. I'm going to write that up there. So using the calculator, and you can go to the formula chart as well. You got the reciprocal. And show you the same thing. This will become CSC. This will become SEC. Okay, so CSC. What should CSCs be? H over Y. Is that correct? Is 39 the H? No, that one's wrong. Okay. Cotangent. What should cotangent be? X over Y. Is that right? Nope. By the way, this is another example of a enhanced problem. Multiple answers. It says select 2 answers. Okay, what about tangent? What's tangent supposed to be? Y over X. That's a good answer. Sine, what is sine? Y over H. So that one is wrong. That means process elimination. This one should be good. What is secant? H over H. It's good. Okay, and I think I have 21 in this. This is a angle that terminates in quadrant 3. Okay, so which quadrant is quadrant 3? Top right, top left, bottom left, bottom right. Bottom left. I'm just going to draw a random angle. And we always connect to the x-axis. It says sine. Sine is y, cosine is x, tangent is y over x. I just said sine is what? Y over h. Do you remember the rule about h? H is always positive, which means the negative has to go with. Okay, you could do Pythagorean theorem here. So on this one, we'll need the Pythagorean theorem to get our x. X squared plus y squared equals h squared. With this formula, I don't ever type in negatives. Because the calculator won't tell you if it's squared, if it's right or wrong anyways. And there's only a potential of messing up on a square. So if it's the Pythagorean theorem, I never type in squares. So we don't know what x squared is. And did I say we never type in squares? I meant to say we never type in negatives. So for y, I'm just going to put 15 squared to avoid mathematically getting the wrong answer. And then h is squared, comma, x. Press enter. I'm getting 8. Did you get 8? Yeah. Now let's look at the graph. Should it be positive 8 or negative 8? Negative. So even if I put the negative 15 for y, it would not have told me negative 8. So you have to get from the graph. It wants to know tangent. Sine is y, cosine is x. What is tangent? Y over x. What is y? What is x? Okay, I'm gonna type this in. And get it as a decimal. So -15. Divided by -8. I know I didn't. Okay, good. The way to make it show you decimal right away.
Yeah.
You don't have to, I just, for the sake of the video, to make it as simple as possible. 1.875, that would be your answer. 1.875. 1.875. And I cannot remember if that's all the analytical trig. It is.